Now, this here is the chart that we have. I gave you it on the paper, but I also have it already filled out for you. So the sheet that you have already filled out is going to be one more of your reference sheets. You'll use it for this here, and that's going to be about it, and for this chapter. And what this tells us is it gives us a way to know for sure if what we're doing is solvable, or how many solutions we should expect to have. Now, at the top, because I don't know if it included it on your printout, we do have this here 1 and 2. Number 1 and number 2. Number 2 is mainly used for solving side lengths, because if we're looking at side lengths, that's the one we're going to use. Because these are the exact same formula, they're just flipped. For number 2, all the side lengths are on top. For number 1, all the angles are on top. So here, this is mainly going to be used for solving angles. Because for 2 angles and a side, well, we'll just mainly need to solve for the other sides. We will need to solve for the third angle, but it's more or less given to us. And in either case, either side, especially for 2 sides and an angle, we only need to solve for 1 angle. Because again, any 3 angles in a triangle add together to be 180, no matter what the triangle is. So you don't have to fill this chart out on your note sheet because, well, you do have it. Okay, I'm just making sure. So now also I will say all the values of A and B that are used throughout this here, we're really talking about a triangle with, stand out, A, side A, so you're here, B, side B, C, side C. So it can work in either form, because most of what we're looking at here is looking at angle A, side A, and B. We could also have done this with angle A, side C, and side A. We could have done it either way. Because really we're looking at the angle and the side opposite, and then one of the other sides. That's all A and B are. So let's use this here and look at the first one that we have. So looking at the flow chart, because we can use this on any of them, the first question that's asked, what information is given? We have 1 of 2 options. It's either going to be 2 angles and a side or 2 sides and an angle. So here, what are we given? 2 angles and a side. Well, if we're given 2 angles and a side, we're going to solve by using the equation number 2 and go from there. Now for this here, what's missing is the measure of angle A. Side length A and side length C. So we're missing 2 side lengths and an angle. We're missing 2 side lengths and an angle. And the easiest one to find out of all this here is going to be the angle. Because the sum of any 3 angles in a triangle is always 180, at least for the Euclidean geometry that we're covering. So what we could do is add these 2 angles together and subtract it from 180. So we could take 102 and add to it 29 degrees. 9 plus 2 is 1, carry the 1. So we get 131. And we could subtract that from 180 and find out that the third angle is 49 degrees. And we could have done that in a calculator. You could have done 180 minus 102 minus 29, and it'd get you 49 degrees. Questions on this here? Questions on anything we've done so far? Okay. Oh, there's part of the 49. Now the formula that they gave us, especially with solving for missing sides, is A over sine of A is equal to B over sine of B is equal to C over sine of C. Now, you don't have to rewrite this out. I'm just writing it so that we do have it, because this is number 2. Now, when we look at what's given, our given information, what side length are we given? For sure. B, yes? So part of solving this here is we'll put side length B over sine of angle B, which is 29. And with law of sines, it's always going to be side length over sine of its angle opposite. Sine of the angle opposite. And I think I've talked about this before. Whenever we set up a triangle with A, B, and C, angles are normally denoted A, B, C, capital A, capital B, capital C. And the side lengths opposite them are always the lowercase of whatever the angle is. So the side opposite angle A is little a. Side opposite angle B is little b. Side of opposite angle C is little c. And they could do it with any of them. So if they name the angles D, F, G, it would be the same thing, little d, little f, little g. They always do that comparison. So here we have side length B over sine of angle B. Now, we need to solve for A and C, yes? Are we given angle A and angle C? Well, yeah, so we can pick either one to go first. Do we want to solve for side length A first or side length C? Doesn't matter. We just need to pick one. So I could pick A, yes? And that's going to be over sine of what? 49. So this works out for us because the only variable that we have is side length A. Everything else is a number. So at this point here, we can get A by itself. So I can multiply both sides by sine of 49 degrees. And over here, these will cancel, telling us A is equal to 28 sine of 49 over sine of 29. Now for most of these here, and again, I would read the instructions. We're either going to round to 2 or 1 decimal places. We're either going to round to the nearest tenth or nearest hundredth. And at this point here, we can plug this into the calculator. Clear that out. Now we can go alpha y equals enter. And on top, we had 28, 49. So sine, okay. You're going to have to give me that number again. I don't know why I keep losing it. 28, 49 over sine of 29. We have this here, yes? I can hit enter, and it's going to give me the wrong answer. Why is that? It's up in the top. It's in radians. We're talking about degrees. So I will need to fix that. So I'll need to go down and tell it I want it in degrees. Now, so if we go to the nearest tenth, it's going to be 43.6. Or if we go to the nearest hundredth, it's going to be 43.59. So we'll do the nearest tenth for this here, 43.6. So A is 43.6. Questions on this here? Questions on anything we've done so far? Not too bad. Now, we can do this again because we still need to find C, yes? So I'm going to erase this here for space. Because I feel like y'all still have a good bit of space underneath that problem, yes? Now, we need to find C. That's the last one we need to find. And it's going to be over sine of 102. Now I need to pick the side and angle opposite it that I want to set this equal to, yes? Personally, I pick the same thing every time. Because what did we use the first time? Side length B and angle B, yes? And I will pick this again, 28 and 29. Now again, we're going to multiply both sides by the denominator, sine of 102, because these two will cancel. And really it's telling me that c is equal to 28 sine of 102 over sine of 29. Questions on this here? There's a reason I picked this here. And I will show you this here, because if we go back to the calculator, and this works on either one, what's the only difference between the one we typed in previously and the one we have now? The 49 is now 102. Well, I can bring it back down by selecting and hitting enter. And replace that one number and hit enter. Because if I can do this easier, especially in the calculator, that I'm not having to retype in the entire fraction, I'm going to do that because it makes it easier to work. So here, 56.5. And that's it. That's also, because once I pick one of them, I always try to pick the side. If they give us a side at an angle that are nice, I'm going to use those every time. Questions on this here? Let's look at the next one. So we have this here. They did give us two angles and a side, yes? So we need to find the measure of angle C, side length B, and side length C. In the calculator, we can say 180 minus 30 minus 45. Because we can just subtract each one from 180 and we get our answer. Because if we wanted to, we could have said 30 plus 45 is 75. 180 minus 75 is 105. We get the same answer. So the measure of angle C is 105 degrees. Questions on this so far? I'm just going to pick side length B to solve first. So we can say B over sine of 45 is equal to, the only side that was given to us was 32, and we don't know, oh well, and then it's over sine of 30. Now, at this point here, scroll. We're going to multiply both sides by sine of 45 degrees, because these two will cancel. And over here, we're going to have 32 sine of 45 over sine of 30. And again, at this point here, we can type this into the calculator. Did it give you 8 square root of 3? 32 square root of 2. Yeah, that's right. Because these here, 30 and 45, are nice angles, because sine of 45 is square root 2 over 2. So we're saying, realistically, 32 times the square root of 2 over 2 over a half. So the half is going to essentially multiply it by 2, so these are gone, which just leaves us with 32 square root of 2. Now, if we did this in the graphing calculator, it would give us a little bit different answer. Well, not different per se. 32 sine 45 over sine of 30. And we get this here. 45.254834. And we know that the scientific or the graphing calculator does not do radicals. It doesn't leave it in radical form. So if I divided it by the square root of 2, we get 32. So it's 32 square root of 2. Does that make sense? I think most of y'all are finding that the 30xs is in some ways a lot nicer than this thing. The graphing calculator does have some nice aspects to it, but the 30xs is almost more useful, especially on most tests. Either form, as long as it's, especially on the test, as long as it's the correct answer, I will take it.
How did you get the 32 graph concept?
This here, so sine of 45 degrees is square root 2 over 2. That's the value of sine of 45. Sine of 30 degrees is 1/2. There's set values that are nice, especially on the unit circle that we have. And at this point, I've got most of those memorized, so I was just pulling those out. Now the 30xs, the yellow calculators that y'all have, will simplify it in radical form. The graphing calculator, 32 second square root 2, that's what it is. It just doesn't leave it in radical form. Does that make sense? I will take either version of the answer. And I'll make sure, especially on the test, I will double check it to see and make sure that you did get the correct values. Because if we wait to simplify later, it does help us out. Now we just need to find the value of C, yes? And for this here, well, my eraser, this is gone. This is gone, and that's gone. This can't go away. Because really all we're changing is what? This is now C, and this is sine of 105. And we're going to multiply by sine of so really we're just replacing the sine of 45 with 105, which tells us that C is equal to 32 sine of 105 over sine of 30. This is going to give us 32, isn't it? 6 over. Yes. Okay, that's right. And there's a reason for it. I don't know why I was hoping that it would be nice. And I can, well, there's a reason for it. Because this is the value, the approximate value that we get. 105 is at a nice angle. 105 degrees. No. What happens if I double it? What's 105 times 2? Is that a nice angle? So the yellow calculator used essentially the half angle formula to find sine of 105 to get us a nice value and then applied the rest. So that's where we get that kind of funky angle or funky length. So this here, we can say 61.8. Especially when you look at the directions, if the directions say round to the nearest tenth, we will want the 61.8. For 32 square root 2, we want the 45.3. But if, yep, and it'll approximate it for us. Now, for really to get the best answer, I like it, especially if we got 32 square root of 2, I will use that value if I'm having to use a side length or try to find another side length. I'll use it because it's more accurate. But we can also use the approximation forms too. Any questions on any of this here so far? We ready for the next one? All right. So here, we're given two side lengths and an angle, yes? Okay, this is where the chart does come a little bit more into play, because if we're given two angles and a side, it's just use side method 2 or use method number 2, and we're done from there. Okay, so given two sides and an angle, is the angle greater than or equal to 90 degrees? Is the angle greater than or equal to 90 degrees? No. Okay, so we drop down. Now the question is A greater than or less than or equal to B? Greater than. So we have how many solutions? One. And that's how this chart's going to work. We're just going to follow those down. Now it doesn't have to be A and B. All this is, and again, this is set up A and the side length opposite go together. So if we were given angle C would take the place of A, angle A, and A spot would be taken by C. Because angle A and side A is just the angle in the side opposite. And B is just the other side. Does that make sense? So as I know in years past when y'all have looked at this, when it deviated from A and B, it really messed with your head. But really, angle A and side A are just the angle in the side opposite. B is just the other side. So here we have one solution. So we want to find angle B, angle C, and side length C, yes? Now we need to use the equation number 1. We have to use equation number 1. Because for us to be able to use equation 2 to find C, well, what? C is over sine of angle C, yes? Do we have angle C? No. So for us to find side length C, we need to find angle C. We can't mess with angle B. Well, we can. We can actually find B or C. We need to find one of them. But I do know for our given formula, because we're going to have sine of an angle over the side opposite of sine of an angle over the side opposite. What is the one side and angle that we have for sure that are opposite of each other? A. We have that angle A is 42 degrees and side length A is 22. Now, I could put C here. Don't write that down. Because if I wanted to find sine of C, angle C, yes? So sine of C would be opposite. Underneath is the side length opposite, yes? Well, what would that be? C. We don't know side length C. I don't know angle C. Can we solve for angle C first? No, because we have two variables, and even at this point, we can only solve for one at a time. So we can't do that. But I can solve for angle B, because the side opposite B is 12. Questions on this so far? First thing we're going to have to do is multiply both sides by 12. These here will cancel, telling us that sine of B is equal to 12. Sine of 42 over 22. And 12 and 22 do have common factors they could simplify, but we're going to leave that for later. Because is angle B by itself? Well, no. There's only one way I can get the angle away from sine, which is with our, try it again, sine inverse. The sine inverse of sine of B, these will cancel, giving me B by itself is equal to sine inverse of 12 sine of 42 over 22. This is part of the reason I didn't reduce the common factors of 12 and 22. Because we could have if sine of 42 was a nice number. But we know unless it's 30, 45, 60, 90, one of those multiples, it's not nice. So we're going to end up using the calculator anyways. Second, sine inverse, alpha, y equals, enter, 12 sine of 41 over 42, thank you. (42 over 22). And we get 21.4 degrees. Questions on this here? Not too bad. I'm curious about something. I was wanting to see how far off the angle would be by that 1 unit. Significant. So the other angle is 21.4 degrees. So B, 21.4 degrees. Questions on how we found the measure of angle B? I have 2 angles, yes? Any 3 angles in a triangle will always add together to be 180. So I can say 42 plus 21.4, which is going to be 63.4, and subtract it from 180. And again, we could do this in a calculator. Now we just need to find the missing side, yes? So we're going to have C over sine of 16.6 degrees is equal to. Now at this point here, it doesn't matter if I pick side length A or side length B. What'd you get? Yes. Thank you. Yeah. My brain had already moved on. Yeah. 116.6. Yeah. My brain, once I'd done the 6 and 8, it moved on to the next step and just dropped it completely. Yeah, so 116.6. And that's also the nice thing with plugging it into the calculator. It doesn't ignore the 1. Thank you. I'm glad that y'all pointed that out now and not me realizing it next hour. Or never. Any other questions on this so far? Now what we have next is I need to pick side length A or side length B. Personally, I pick side length A. And the reason I pick side length A is side length A is 22 and the angle is 42 degrees. So we'll finish this up shortly. And the reason I don't pick B is we had to approximate the angle. I try to keep nice numbers if I can. So we'll have 22 over sine of 42. And when we multiply, we'll have 22 sine of 116.6 over sine of 42. And if we do this in the calculator, 22 sine of 116.6 over sine of, so 29.4 is our length. Now, if you're not sure of how they look, relate them to the angles. Biggest side is opposite the biggest angle. Smallest side is opposite the smallest angle. And if we put this in, C is indeed opposite the biggest angle, so it is set up correctly. We will finish